Hello, everyone, and welcome back to your own channel, Capsulated Breakthrough. This is your friend Said Irfan. I am pursuing electronics and communication engineering in Sri Venkateswara College of Engineering, Yelahanka, Bangalore. Right, so today we're back again with another new topic, which is on microcontrollers. Exactly. We are back to our own base as we are the student of EC, Electronics and Communication. Microcontrollers holds a great weightage. So we are today discussing about the microcontrollers, and the topic today is understanding the pulse width modulation (PWM) using C programming. So we'll be understanding what does PWM mean, what does it do, and how can we implement pulse width modulation in C programming, using C programming, right? So it is again, I'm Irfan, my UFN is 1VE22EC114, and I am pursuing my electronics and communication engineering in Sri Venkateswara College of Engineering. As you all know, if you've been watching my previous videos, we have no time to waste because we have a certain bandwidth of time. Without wasting much time, let's begin with the main video. Okay, so what is PWM? So starting with the basics, what is PWM? What do we mean by pulse width modulation and how does it work? Right, understanding pulse width modulation in electronics. What does it do? Pulse width modulation reduces the average power of an electric signal by breaking it into discrete parts. What does it do? See, for example, we have a big signal. What does PWM do? It breaks the signal into significant small parts so that average power of an electrical signal can be reduced. The power which is required to process the signal can be reduced. If we send the whole signal together, we would need a lot more power than if we break signals into small parts, then the average power required would become less, right? So this is why PWM plays a very crucial role in signal transformation, where it becomes easy and power efficient with the help of pulse width modulation. Application in the motors control. PWM is widely used in motor control applications to regulate speed and torque efficiently. See, motor control, we've seen in our vehicles, in fast moving vehicles, motor control system is given so that you can access brakes, you can access efficient speed and torque with very high speed and very uh, a quick speed up in vehicles. That is where PWM plays a very crucial role in light dimming. Light dimming also. Okay, PWM is employed in light dimming applications to adjust brightness level efficiently. PWM also helps in automatic transformation of light dimming in vehicles, in mobile phones, so many more. Okay, and signal modulation. PWM finds application signal modulation encode information in a waveform. Okay, so these are the three main applications of the PWM pulse width modulation. One, it is used in motor control. One, it is used in light dimming, and the other, it is used in signal modulation, as we discussed in the first point. Okay, so what is the basic principle of PWM? On what principle does PWM work? Let me get my yeah, great. So PWM is a technique in which the duration of the on time of the pulse width of a signal is varied while keeping the overall frequency of a signal constant. A huge para again. Let's break it down and understand what this has to tell us. PWM is a technique in which the duration of the on time, the timing on the pulse rate when it is on of a signal is varied by keeping the overall frequency very much constant. The whole frequency is constant. Only thing varying is the on duration of the pulse width in PWM. With this, we can break it into parts and send it, right? So basic principle of PWM is understanding duty cycle frequency and amplitude. Pulse width modulation is a modulation technique sorry, used to encode messages into a pulsing signal by varying the width of the pulse. See, we've got a message and we've sent this message into analog form. And to do that, PWM is very important. And PWM, what does it do? It sends the pulsing signal into various width of the pulse with a different width of the pulse so that the signal can be reached to the receiver without being lost, right? What is frequency? Frequency, it indicates how frequently the PWM signal completes one cycle in a second. Simple. The PWM, how much cycle per second PWM can complete, it is called as the frequency of the PWM. Coming to the duty cycle, it is the proportion of a time of PWM signal is in active state. On how much time is the signal active or in on state in a PWM in one cycle, it is called as the duty cycle. I hope you've understood this. Going on to the next slide. Okay, I don't know why it takes time, but it takes time. Okay. Visualizing the modulation pattern. So we've understood what is PWM. We've understood the applications of PWM. We understood how it is used. Now we have to understand the visualization of PWM because we are visualizing PWM. The topic is pulse width modulation with C programming, if you remember. So we have to visualize this with the help of C programming and how can we use this in C programming, right? So for that, visualizing PWM, exploring pulse width modulation through C programming. We have to understand it through C programming, and for that, we have certain important points we have to write in the checkbook before using the program. Right, the analog output generation. The most important thing is getting an analog output. See, we get an analog input, we digitalize it, we get digital inputs, we send it to analog signals, and then we receive an analog output. So, generation of an analog output through BWM, analog like waveforms can be generated digitally by varying the duty cycle. Right? We've discussed what duty cycle is. 75% of duty cycle, which means with 75% of duty cycle, the signal remains high for 75% of the total period of time, which means if, if the processing time period of a signal is 100% and if the duty cycle percentage among that is 75, it means that the whole signal will be in an accurate, remains in high in 75% of total time. The other 25% duty cycle is the signal of high 25% total period of creating specific modulation. Right? The frequency and duty cycle relationship, the frequency of a PWM signal impacts the resolution while the duty cycle influence the average voltage of the output. Time division multiplexing TDM plays a huge role in this also, in the other stuffs also. So TDM plays a very big impact, right? 50% of duty cycle, 50% duty cycle results in an equal high-low signal duration demonstrating a balanced modulation process. So it balances the whole process, right? I hope you understood that. Going on to the next. Okay, PWM in C programming, the implementation steps. What are the major steps you have to go through in PWM if you have to encode it in through the C programming? Mastering pulse width modulation with C programming first is setting up the environment, right? Selecting the appropriate microcontrollers and configuring the integrated development environment IDE for PWM. The app IDE, the development programming, where you can program the microcontrolling systems about the PWM, right? Writing the PWM code. Once you set up the program, once you've got the application done, once you've got the initial process done, the next process comes is about the writing the code. The most important among all the process. Because if you have the code, you can change, you can run it, you can do whatever you want it with it. Right? Initialize the PWM module, specify desired frequency, fine tune duty cycle to achieve the intent PWM signal characteristic. Simple, we have to find the PWM module, the module in the programming language where you have to encode it, give the desired frequency you want, give the desired duty cycle to achieve the PWM with the specific characteristics you want. Right? Then testing the PWM signal. After you've encoded, the next basic process is running the code, testing the code if you have written proper code or not. And for this, thoroughly test the PWM signal to verify the functionality and behavior, ensuring it aligns with the expected output. Make sure you have to get the output which you've expected. Whatever code you take, whatever the program you take for pulse modulation, you have to get the expected output. That is the most basic rule of coding anything in C programming. Right. On to the next slide. Sample code for PWM. So this is the sample code for PWM on how we can write the code, right? First, configure time counter, the code snippet configure time counter for the PWM generation by setting a specific bits of waveform generation mode. Then set up prescalar to 64. So what is a prescalar to 64? A prescalar value of 64 is a set to define the frequency of the PWM, then set initial duty cycle, initialize PWM, main loop execution, that is the steps. Okay, I don't know what happens to this in the middle, it just gets stuck. Not the issue with my laptop, guys. It is really good, great moving laptop, but I don't know if it's the app or if it's the sharing. Come on, man. Yeah. Okay, now after we've discussed how we can code it, what are the main points we have to code? See, in this video, there is no code. I'm not giving you the code. I'm just telling you what is to be done, how it is to be done, right? So code is your own duty, your own headache. You have to find the code out. It's not our duty, right? Advantages and disadvantages of PWM. Exploring the strength and weakness of pulse width modulation. So what is the strength? What is the weakness? See, everything has a strength and its weakness. Nothing in this world is too powerful that it has no weakness. So even PWM has its weakness. Let's go through what these are. Enhanced power efficiency due to the reduced power losses. There are very less power loss. So it has enhanceability in its power efficiency. Precise control over the output signal, power and speed. It has a huge grip in its output signal, good frequency, good speed. Maximum PWM is amazing, right? Lower average output or power allows for battery thermal management, great battery management, and then widely used in applications requiring analog-like control. Great. Potential electronic interference EMI issues, it has a little issues. Only two of them. That is one potential electromagnetic issue. Then it is very complexity in implementation and design. Designing part is complex. Designing part of PWM is very complex. That is the one I could call a back thing, which is to be changed in future. It can be made more simplified in future, maybe. So waiting for that time to come. Higher cost associated with the required hardware. This the hardware required is usually costly, so might not be affordable by everyone. So even maybe that with the implementation of your data industries can be solved, not a big issue. So basically, it's a win situation as PWM has greater advantages than its disadvantages. On to the next style, application of PWM. Where do we see PWM? We just saw it in a previous slide, discussing it to a more further extent. PWM can be seen. First, power control in amplifiers. Regulate powered output in amplifiers by modulating the pulse width, ensuring efficient operations. Next, the motor speed control. PWM enables precise and efficient speed regulations in the motor speed control. The third, signal generation. The waveform signal generation, PWM plays a huge role in digital system through pulse modulation. The fourth, sorry, dimming light, LED dimming. Control the brightness of LEDs by adjusting the duty cycle by using PWM signals. Great. On to the next slide. See, I was very fast in this slide because we've discussed almost all of these points before also, not wasting much time. On to the next slide. See, we have to understand. See, if there's something we've been using today, it is discovered, in the history. So we have to trace back this to understand what's happening today and how much more chances of development are there in future. So for that, we have to understand when it was started. Back in the timeline, in 1990 was the time when early utilization of PWM in DC motor control for improved efficiency and speed regulation for use, right? Coming to 2000s, integration of PWM technology in LED lighting system for brightness and control energy system. And then, so 2010, the progress adoption of PWM is advanced renewable energy system to optimize power generation. And I hope many more of the uses of PWM can be used in the upcoming future. Let's pray for it. Let's hope for it. And let's support the industry for it. Right? So let's become a good engineer. I hope so. On to the next slide is the conclusion one people. The background of use is quite similar because even at launching rockets, a lot of electronics is used, and a lot of electronics use a lot of PWM is behind it. So everything put together makes a good deal. Conclusion and the future of the PWM. See, PWM is versatile and efficient modulation technique, no doubt about it. It is used in controlling power delivery and signal modulation. Yes, understood. Key applications include motor control, LED dimming, and audio signal processing. These are the three most important things we have to understand. Then PWM offers several advantages such as high efficiency and precision, but also has a drawback like EMI and switching noise. These drawbacks can be recovered very soon. So that's it. I hope, yeah, that's it for today. And I hope you found this video informative. Basic things we've gone through in this video is that the key applications of the PWM, which is the LED dimming, motor control, and signal processing. Advantages is that it is a high. Disadvantage is that the AMI and the switching noise, and we've seen the blueprint of the code, not the exact code, but the blueprint and a roadmap of the code of with PWM using C programming, right? So I hope you found this video informative. For many such videos, you know what is to be done. Like, share, subscribe to all of your loved ones, to everyone who's enthusiastic in EC. And until next time, you know what to do. Till that, see you. Sayonara.